Assalamualaikum and a very good day to my panel, Dr. Iwan Ghazali and Dr. Khairul bin Hamzah. My name is Muhammad Nazrin bin Zakaria, a student of Bachelor of Manufacturing Engineering Technology in bracket Product Design with Honours. As in beautiful day today, I would like to present to you my final year project report entitled Design for Manufacturing and Assembly TFMA Newly Developed 3D Router Machine with the help of my supervisor, Madam Umi Hayati binti Ahmad, and my co-supervisor, Dr. Hambali bin Poijang. Alhamdulillah, these theses are done within the duration given. Let's proceed to the next slide. So in this presentation, I will talk about three chapters, which are Chapter 1, the introduction, Chapter 2, the literature review, and Chapter 3, the methodology. I will go through more detail chapter by chapter. I will start with Chapter 1, which consists of the project background, problem statement, research objective, and scope of research. The project background is about a talent development program (TDP) with its motto, Developing Tomorrow's Engineering Expertise. So TDP is a program where a group of students under one organization invent a large-scale project called CNC 3D router machines. Fundamentally, this is the first program that was developed with the Dean of the Faculty Mechanical and Manufacturing Engineering Technology and other department heads support. This program aims to expose students to real-world situations when entering the industry and to provide students with real-world experience in learning something outside their comfort zone. The next slide is about the problem statement and research objective. The problem statement in this project is that, first, students lack the knowledge to develop a CNC 3D router machine. CNC is a very detailed and complicated machine in various ways, from the material used to the wiring part to the programming part. It is quite critical for the students without enough knowledge. Second, the effectiveness of the FMA analysis in developing a CNC 3D router frame structure is uncertain. This is due to the data, which are not being gathered yet, might be not enough to run the simulation. The third problem is the developing an affordable CNC machine. As we all know, CNC machine nowadays is very expensive, creating a barrier for those who run small business and do not have the financial capability to purchase the 3D router on the market. Next is about the research objective. My first objective is to design and develop the CNC 3D router frame structure, and my second objective is to provide a systematic procedure for analyzing the design of a CNC 3D router's frame structure from the point of view of the FMA. In this project, my scope of research is included the literature review on CNC 3D router frames structure improvement using the TFMS approaches, conducting the FMA to identify design problems and generate remedial design solutions, and the SolidWorks software as a modeling drawing of the CNC 3D router frame structure. That is all from my chapter 1. Next, I will proceed with chapter 2, which is about the literature review. In this topic, I will talk about the new product development (NPD) and the details of engineering design phase and CNC. According to Hambali Boyjang 2021, the NPD is a collection of activities within integrated development phases that include product planning, ID development, manufacturing, production, sales, and distribution, in which a product is developed based on the demand and requirement of customers. It is also common knowledge that the NPD differs by industry. Simply said, this is dependent on the firm's circumstance, such as the source of project or design solution accessible, knowledge and capacity, as well as financial strength. Regardless of the product type, a well-defined NPD is critical to project success for better product quality, information, and communication through task coordination and development team assignment, project scheduling, timing, performance benchmarking, and cross-checking process for future projects. As a result, having a well-structured NPD process is critical to the overall success of a product development project. As in this slide, there are 6 phases made by Aurich and Eppinger. The phases include the planning phase, concept development phase, system level design phase, detailed design phase, testing and refinement, and lastly, production ramp-up. For this project, I am using the NPD process made by Dr. Hambali bin Poijang from the book of Product Design and Development. This development process flow is made under the TDP program. There are 4 phases altogether in the NPD process, which is Phase 0, Phase 1, Phase 2, and Phase 3, contributing to the CNC3D router machine. Phase 0 indicates the planning phase, while Phase 1 is called the development phase. Next, Phase 2 represents the pre-production phase, and lastly, Phase 3 is the launching and production phase. However, for this CNC3D router project, our team only managed to proceed until the early of Phase 2. This is due to our project goals only aiming for a beta prototype, or in other words, a functional prototype, after having discussion with our supervisor. The next slide is about the engineering design process, EDP, which is a method of thinking that is iterative rather than linear and is located in phase 1, which is the development phase. According to Martin Rees, 1999, the EDP was founded at the end of the 19th century with the goals of systematically addressing technical problems, and it utilized both creative and rational techniques. The EDP promotes the development of a sort of engineering thinking that may be used in a variety of educational settings, including the enhancement of students' creativity and problem-solving ability. In this slide shows the design phases made by Eggert model in 2010. In the design phase, there are 5 steps to achieve the process, which are the formulation, the concept, the configuration, the parametric, and the detail. In some industries, only 3 steps are usually used in the design phase, which are the formulation, preliminary design, and detail, while some others are only using 4 steps in the design phase, which are the formulation, concept, embodiment design, and detail. In my DFFA scope, I will go through until configuration design because parametric and detail are not included in my scope. For a variety of reasons, formulating a problem statement is a difficult cognitive effort where it needs students to arrange the problem in terms of objective, constraint, function, and assumption, all of which must be articulated in engineering specification. According to John Wiley and Sons, 2009, when solving a complicated case, students have to formulate and pose questions and swift through answer and information. So the first thing to formulate is seeking information by gathering information from a variety of sources, including surveys and research to gain comprehensive picture of the consumer, gender-specific demands and competitors. Next is interpreting. While translating the raw data, collect as much information as possible about the part assembly or product's unique functional requirements, targeted performance objective, necessary limitation, and assessment criteria. If the information is too broad or ambiguous, go back to the source and dig deeper. Next step is gaining consensus. To reach a consensus, team members discuss their interpretation of the data, modifying their conclusion, and if required, improving the data source. After that, they create a preliminary engineering design specification, which is a written summary of the issue. Lastly, by obtaining management approval, which means the team deliver the preliminary engineering design specification at a design review meeting or in a memorandum technical report to keep management informed and secure their approval. A concept design is a rough description of the product's technology, functioning principle, and shape. According to Eggert J. 2005, concept design is a phase in the evolution of products when alternative design concepts are generated, evaluated, and selected for further development. In this slide, there are 2 concepts that will be discussed in the concept generation and concept selection. I will go through them one by one. The first one is concept generation, which consists of a clarifying problem, external information, in-house information, systematic combination, and a review of the result. Under the concept generation, I am using the systematic combination, which will be shown in detail in methodology. Next is the concept selection, which consists of external decision, voting, pros and cons, prototype, and test. And lastly, weighted rating method. Under the concept selection, I am using the weighted rating method, which also will be shown in detail in methodology. Next, in the configuration design, I will discuss the design for manufacturing and assembly (DFMA). DFMA is a technique for increasing adaptation and efficiency in the face of change. According to Pedro, 2006, this idea can affect the use of the experience to previously done mistake to speed up the development process and also accomplish new technologies and philosophies to ensure that activities that faster give more precise results that can reach this target. DFMA is combination of design for manufacturing (DFM) and design for assembly (DFA). According to Boothroyd, 2002, DFM is the manufacturing of individual parts of product or assembly, while DFA is the addition of joining of parts to form a complete product. Computerized numerical control (CNC) machines are broadly used all over the world. There are many types of CNC machines on the market. Unfortunately, the cost of design is too high for the end user and requires a lot of work in terms of design and assembly time. As a result, DFMA can assist in improving design efficiency, cost, and client needs. The requirement in this study is that when redesigning parts, the parts function must be the same as the original. Thus, the study purpose is to calculate the current design efficiency of the CNC machines and the modification of the current design by eliminating and simplifying some of the parts to achieve a better design and more convenient for the others. This is the example of CNC machine, which is a CNC plasma cutting machine and CNC water jet cutting machine. There are phrases by Bill Gates saying the only thing you control in life is the programming of your mind. Next, I will explain the chapter 3, which is about the methodology. This chapter includes the tools and methods that I will be using in this project. I will explain in more detail about each tool and method. This is the methodology process flow. The process flow shows the overall project direction. It starts with a literature review and ends up with the fabrication part, which is a beta prototype. It is divided into two parts, which are for final year project 1, only cover until engineering design, and final year project 2 will cover the functional prototype. First and foremost, SolidWorks software. SolidWorks software is used to design the CNC 3D router machine, but in my scope, I will only design the frame structure part. Once the design is ready, I will get the data needed to put in the DFA software analysis to simplify the CAD design and increase the design efficiency. This is the example of DFA software. Next, I will collect the competitive benchmarking information to gather many types of data such as the material, weight, price, features, etc. This table can help me narrow more data to develop the right way for the 3D router frame structure. Next is the combination table of concept, which is the same thing as systematic combination as in chapter 2 just now. The combination table guides me systematically in selectively considering the combination of fragments. Once the combination table of concept had done, the data will be expanding more detail in the table of the total number of combination. The formula to create this table is features 1 multiplied by features 2 multiplied by features 3. The answer is the total summation for the table of the total number of the combination. In this project, the weight rating approach will be used to develop the ideal selection of the frame structure sub-assembly B2 router machine. The weight rating method is a project management technique used for weighing certain decisions, such as prioritizing project action, prioritizing the development of product features, purchasing new software, etc. The weight rating method can be used for all kinds of decision and action. In terms of project management, this model can help me figure out my priorities during the planning phase of the project lifecycle. In the DFA analysis, certain crucial information about the assembly must be entered before the individual pieces can be analyzed. The data and questions to be applied to the various components of the assembly are determined using this information. So this is the Gantt chart for my PSM1, which will be held from March 2022 until January 2023. So the expected result for this project in terms of DFMA research scope, the part count will be reduced, the assembly time will be less, and the design efficiency will be improved better. With all the tools and methods that I have shown you before, it is not possible to achieve such a result. Now, for the conclusion, TDP program is very useful for students as a preparation to get into the industry. To develop a new product, it is very important to have a knowledge about NPD process, design phase, engineering design, etc. And the last one, it is also very important to create the flowchart process and to follow every content with a specific time duration. That is all from me. Thank you so much.